Hello everyone. In this video, we will be doing class 9 science chapter 1 matter in our surroundings. Okay, so before we go any further, let us try to list a few of the many things that we come across every day. Right now, let's say we have air, we have water, we have books. So all these things, right, they are categorized as matter. They are categorized as matter. Now, so what exactly is matter? How is it defined? Now, matter is anything that has mass and occupies space. When you say mass, okay, it's nothing but weight. And when you say it occupies space, that means it has volume. Now, let us just consider the case of water here. Okay. Now, let's say it's half filled in a glass. Okay. Now, if I pour more water and then fill it to the brim, right? Let's say it's full. Then obviously this glass of water will become heavier, right? Will become heavier. So that means the water is adding weight, right? So water has mass, and then now it's full. Now it's full, and then let's say I keep on pouring it. Okay, the water will start to spill, right? Now the water will start to spill because the space that is there in the glass is already occupied. Okay, so water is occupying space, so water becomes an example of matter. Okay, so matter is anything that has mass and occupies space. Now if we talk about shadows, okay, shadows and sound and heat. Okay, now all these things, okay, um, this does not satisfy the definition of matter. It does not it does not have mass, neither do they occupy space. So these are non-matter. Okay, just these are not considered as matter. Okay. So this is just to give you a little idea about it, so that you can be aware of it. Now coming to classification. Early classification of matter was done by Indian philosophers, and they classified matter in 5 basic elements, that is air, earth, okay, air, earth, fire, sky, and water. Now these basic 5 elements all together collectively they were known as the Panch Tattva, right? And later on the Greek philosophers also came to a similar conclusion, and then they classified matter into these 5 basic elements. Now if you consider this element, this classification, okay, this is kind of very generic in a way that see, science is all about validating theories. Okay, so in order to understand matter in a better way, um, there had to be a kind of classification that is more specific. So modern day scientists, they came up with 2 types of classification. The first one is based on the physical properties, and the second one is based on the chemical properties. And in this chapter, we will be studying the first one only, which is based on the physical properties. Okay. Now the next topic is physical nature of matter. Matter is made up of particles. Okay. So for this we will go through the activity 1.1, but we will not go into the specifics of it. Okay. Just consider a glass of water. A glass of water. Okay. And let's say you put some sugar. Okay. And so let's say you have dissolved the sugar. Okay. Then what happens when you dissolve the sugar? The sugar disappears, right? The sugar disappears. right? Now, here's our first question: where does the sugar particles disappear? Now, in order to answer this, we have to employ the idea that matter is made of particles. Okay, so uh, just visualize it this way. You have your water particles this way. Okay, you have water particles. You have water particles this way. Now, what actually happens when sugar is dissolved is that the solid blocks of sugar, they disintegrate. Okay, they disintegrate, and then that also into um, its own particles. Okay, millions and millions of them that are very very tiny. Okay, and they go and occupy the spaces in between the water molecules. Okay, right. So they go and occupy the spaces in between the water molecules. Okay, so that is where your um, sugar particles disappear. Right. Now, does the level of water change? Now, according to the definition of matter, okay, um, sugar is also matter, so it will definitely occupy space. That means the level of water should rise. Okay, but here in this case, the answer is no. Why? Because when sugar dissolves in water, it disintegrates, and then and its particles, instead of occupying its own independent separate space, they go and occupy the spaces in between the water molecules, right? Spaces between the water molecules. Okay, so the level of water does not change. Now, how small are these particles of matter? Just look at this picture, the first picture, okay, and we'll go through the activity. Uh, Take 2 to 3 crystals of potassium permanganate and dissolve them in 100 ml of water. So we have dissolved the potassium permanganate into 100 ml of water. Now consider this as this glass of water. Okay, the first glass, then label it as second, third, and fourth. Right. Now take out approximately 10 ml of the solution and put it into 90 ml of clear water. So what do you have to do? What do you have to do here? You just need to take 10 ml of the solution from the first glass and then put it into the second glass. Then we'll have to continue the process. Okay. And again here. Okay. Now what we're observing here is that the shade of color, okay, the shade of color is becoming lighter and lighter and lighter. Now, see, what we're basically doing here is we are decreasing here and we're decreasing the amount of potassium permanganate while at the same time increasing the volume of water, right? So now here, even though the shade of color is becoming lighter and lighter and lighter, there's something very obvious. That is, coloration is taking place, right? So from this activity, we can conclude in a way that um, a very tiny amount of potassium permanganate crystals must be having an unimaginably large number of particles in them, okay? And that these particles must be unimaginably very small, okay? Now, characteristics of particles of matter. Particles of matter have spaces between them. Now, in the first activity, we came across glass of water where had particles in them. Then sugar particles going in between, right? sugar particles were going in between. So, so we can simply conclude that the water particles, okay, they have spaces, right? And these spaces, they are called as intermolecular spaces. Okay, intermolecular space, right? The spaces between the particles of matter, they are known as intermolecular space. Now, coming to the next topic, particles of matter are continuously moving. Just have a look at this picture, okay? Now, what you'll observe here is we're putting a little potassium permanganate in the glass of water. Now, without even without stirring, the water is getting colored here. Okay. Now, what does this suggest to us? Okay. This suggests that the particles are continuously moving, right? So, like here in this case, the particles of potassium permanganate, they are randomly moving in all directions, so it reaches out to the to every part of the water, and then the water gets colored, right? So particles of matter are continuously moving. Okay, this is what it suggests. Now for this, we have three activities in the textbook. Okay, um, which we'll simply go through. Again, we'll not go into the specifics of it. All right. Now, come to the first activity. Uh, Consider an incense stick, okay, kept in the corner of your room. Now, let's say it's unlit. To get the smell of it, you have to go close to it. But once you lit it, what happens? In no time, the room is filled with that scent of the incense stick, right? Why does that happen? That is because there are particles in the smoke, okay, that belongs out from the burning incense stick, and since particles of matter are continuously moving, okay, those particles, they reach out to every nook and corner of the room, okay, and so that is why even though if you are far away from it, you get the smell of it.